Anytime a chemical change happens, chemical bonds are being broken and new ones are being formed. These tiny circles that are different colors are different elements. This is actually hydrogen peroxide, which can break down into water and oxygen. When we talk about substances before a chemical change, we call them reactants. So everything that's on the left side of this arrow is a reactant. And we say that anything that's on the right side of that arrow is a product. Later in the year, we're going to get to this simplified way in which we write chemical equations, where we show the numbers of molecules using these coefficients. These tiny subscripts are telling us how many atoms are contained within that molecule. When we perform a chemical change, the bonds between the original substances are being broken and new chemical bonds are being formed. The law of conservation of mass is a simple statement. It simply says that the mass of my reactants is always the same as my mass of products. We can't just magically create or destroy atoms. All four of these oxygen atoms are accounted for on the other side of this equation, just as all of the hydrogen atoms are also accounted for after the reaction. Atoms can recombine, but when they do, they don't disappear. They just form new substances. Using this law, we can make mathematical predictions about chemical reactions and the mass changes that occur. In an experiment, we have 100 grams of red mercury. It's red mercury oxide. It's placed in a flask and it's heated until it breaks down into liquid mercury and oxygen gas. The liquid mercury has a mass of 9.25 grams. What is the mass of oxygen? When I have a word problem such as this, I like to change it into a symbolic equation. Even though we don't know what the formula is of mercury 2 oxide, we do know that it's the only reactant. Likewise, we know that mercury and oxygen are the only two products. So even though I don't know their chemical formulas, I'm still going to write it as this skeletal equation. I'm also going to use this as a way to organize my numbers. Since I have 100 grams of my reactants, and I know I have 9.26 grams of mercury, I'm also going to write that below. My goal is to find out how much oxygen reacted, or how much oxygen was left over after the reaction. Well, if I started with 100 grams and I have 9.26 grams of mercury, then the amount of oxygen would simply just be the difference between these two numbers. So 90.74 grams would be the remaining mass of that 100 grams. In this situation, I want you to see if you can set up a skeletal equation just with words, kind of the same way that I did in the previous problem. Can you find out how many grams of the compound formed if you have this information in this table? Take a moment, pause the video, and see if you can work this out. So in this reaction, I have aluminum plus bromine yields compound, whatever that compound is. Before the reaction, I obviously have 0 grams of this compound, but after the reaction, I'm trying to figure out how much I had. I know that I have 8.2 grams of bromine after the reaction, which means that only some of that 100 grams actually did react. The aluminum is gone, though. The aluminum completely reacted. So my mass of aluminum before the reaction was actually 10.3 grams. The mass of my bromine is actually a difference between 100 and 8.2 grams. And that comes out to be 91.8 grams. Then, to find the mass of the compound, all I have to do is add these two numbers together, because both reactants' masses should be the total mass of the compound after the reaction, which is 102.1 grams. We're going to go over some basics of the periodic table in our next mini lecture.